Okay, parts E, F, and G. Let's have a look. So Sam plays a game with the spinner and the coin. Each is spun once, and Sam calculates his score S as follows. So just to make it clear, you only do them both once. Okay, so we have to combine them. We need to multiply them once each. So let's have a look at what happens. So if x equals 0, we get this result. Then s equals y squared. If x doesn't equal 0, then s equals x times y. So that seems quite easy. Now, part E, show that the probability s equals 30, then you get 112. Find the probability distribution s, and of course, find the expected value s. Now, as always, I always find it easy to do the probability distribution first, because if you can get this one right, every single thing will be easy to compute. So let's have a look. Let's start with the first condition, if x equals 0. So right now I'm going to draw a probability distribution, a very simple one with s and the probability of s. Okay, just draw a nice, oh my god, that's not even a straight line. And just try and fill it out. Okay, let's have a look. So now when x equals 0, what are the options? You get y squared. This means you have 2 squared or 5 squared. So I'll do this in blue to represent. So 2 squared is 4, 5 squared is 25. Now let's go ahead and solve the probabilities regarding them. So Sam plays a game, and what do we know? Each is spun once. So when x equals 0, I mean you get probability 112. Then you pick y, whatever letter you get. So if you get y is 2, then you'll be 112 times 2/3. So this would be exactly 4/36. For 25, for the y case, when you get 112, you 112 multiply 1/3, and that will give us 1/36. So this is quite easy, this one. Be careful not to square these values, because remember, you're only spinning it once, not twice. Even if it says y squared, it means that your final score will be y squared, not the probability is y squared. So that's one thing to take into account. Okay. Now let's look at the second case. Let me just put the red pen. So if x doesn't equal 0, then the score will simply be x times y. So we have combinations. We can say 3 times 2, which is 6. We have 3 times 5, which is 15. We have 6 times 2, which is 12. And 6 times 5, which is 30. Okay. Now for the sixth case, so to get 3 and 2, it would just be 2/3 times 2/3, which is 4/9. To get 15, it would just be 3 times 5, so 2/3. And 1/3 is 2/9. What else do we have? 12. 6 times 2, so 1/4, and 2/3 will make 12, so multiply them. And the last one, which is actually the solution for part E, is just 1/4 times 1/3, which is 1/12. Okay, I think the red ones are quite straightforward, but the blue one is a bit tricky. It just depends if you didn't catch this statement out here, spun once. Okay, so just once you use it here, and of course your default is 112, because that's when x is 0, we know that. Okay, that's good. So let's move forward. So show that probability s is 30. Well, just to actually show it, just say probability x equals 6 times probability y equals 5, and just fill out the numbers. So this was 1/4 times y equals 5 was 1/3. And that should give us 1/12. Now, last one, part G. So find the expected value of s. Okay. This is just like always, you just do s times the probability. So 4 times 4 is 36. So this will give us, actually, let's just keep it in this format. So you literally just keep doing this. You just multiply up and down, yeah? And you keep on doing this until you get to the final one, which is 30 times 1/12. And you should get about 137/12. And that is the same as, yeah, about I'm not sure if it's a big deal, but 11.42, 2 decimal places.